Hi students. Today we'll talk about similar polygons. This is the second lesson in this new unit. You've heard about polygons before. We talked about all the different types, pentagons, quadrilaterals, octagons. You've also learned about similar back in junior high. So we're going to put those together along with the ratios and proportions that we've been talking about. So if you recall, when we learned about polygons, a polygon is just a closed figure with straight sides. So polygons that are similar, they have to be the same type of polygon, but they also have to have the same shape. So for example, even though two polygons might be triangles, they might be different types of triangles. So they wouldn't be the same shape necessarily. So they have to have the same shape, but their sizes are different. So it's kind of like a mama and a baby. So for example, if I had this mama and this baby, we might say that those are similar. However, if there was another baby that looked like this, he would not be similar to his mother because he's not the same type of shape. Let me show you another one. So what if we had, let's say, a pentagon, right? It's 5 sides, right? But I could draw another pentagon that's either bigger or smaller that doesn't have the same shape. So for example, I could draw another 5-sided shape. Those are not the same shape, so those would not be considered similar. But if I drew the exact same shape but maybe just a little bit smaller, those two might be considered similar. Okay? We're going to learn how to tell if two shapes truly are similar. What must be true? So the first thing that must be true is that corresponding sides have to be proportional. So sides that correspond must be proportional, not the same, but proportional, which means I could use corresponding sides and make ratios that are equal. That's what a proportion means. Okay, so remember a proportion are two ratios that equal each other, right? So we'll talk about what that means in a minute. The other thing that must be true in order for polygons to be similar is that corresponding angles are congruent. So the angles that match up or correspond are exactly the same size. They're congruent. So angles must be the exact same size, and sides are just proportional. So we're going to look at those two things with some different polygons. Okay, example 1. Use the similar figures below to answer the questions that follow. So we're told they're similar. There's also this symbol here. This is the symbol for similar. It's kind of like what's at the top of a congruent symbol, the equal sign with the little wiggle. It's a little wiggle. I don't know what it's called, but it's a symbol for similar. So if you see that, you know that the sides are proportional and the angles are congruent, corresponding sides and corresponding angles. So A says, what must be true about the angles? The angles, remember, have to be congruent. They have to be equal. So let's look. Angle A, I can see, is congruent to angle E. So the measure of angle A, or angle A, is congruent to angle E. That means their measures are equal. Angle B is congruent to angle F. Angle C is congruent to angle G, and I can tell all these by the number of the number of arcs in the angle. Remember, that tells you which ones are congruent to each other. And then the last pair of angles, D and H, are also congruent. Okay, so remember, in similar figures, corresponding angles are congruent. They have the exact same size. If they didn't, if one of the angles was slightly larger, slightly smaller than the corresponding angle, you wouldn't have the same shape anymore. The second thing that must be true is that, remember, the sides have to be proportional. Just going to abbreviate proportional. So if I take two sides that match up, and I can tell by the angle markings which sides match up. So for example, this 5 is going to correspond with this 2.5 because they both connect the 1 arc and the 2 arc angles. Okay, so what you do to show that sides are proportional is you make ratios and show that the ratios are equal. Okay, so according to this, they are going to be proportional. So I could say side AB over side EF, the length between A and B, over the length between E and F is going to equal another ratio of two corresponding sides. Maybe, let's see, maybe this 10 and this 5. So maybe we'll say that that's equal to the length between A and D compared to the length of EH. Okay, sorry, EH. My mistake. Okay, so look again. AB over EF equals AD over EH. Okay, we've got two other pairs of sides also. CD corresponds to GH, so I can make a ratio. Now notice I'm making all my ratios in the same way. I'm taking the side over here on the left and putting it on top of the side over here on the right. So I'm doing left over right. It doesn't really matter as long as you're consistent. So I'm going to say CD over GH. And then the last two pairs of sides are the remaining sides. That's the 6 and the 3. So BC is the one on the left, and FG is the one on the right. So if I plugged in numbers into all of these ratios, they would all equal each other, which means they are proportional. Okay, all of these ratios are equal, which means the sides are proportional. I want you to know what that means. The other term we need to talk about is scale factor, and you may remember this one from 8th grade or 7th grade. And we actually showed you some scale factors on the previous example, but it's the ratio of the lengths of two corresponding sides. So if you take two sides that correspond, you make a fraction with it, boom, that's your scale factor. Now, depending on how the question's asked, there's two ways to set up the scale factor. And the two different ways are going to be determined by which side goes on the top versus which side goes on the bottom. So the way that we want to remember this, the scale factor equals new over old. And I'll explain what that means in a minute. New over old, know this. Highlight it, put it somewhere safe. You also might look for some key words in your sentence that also helps you know what the new and the old is. The new should be after the word to, and the old should be after the word of. Okay? So you could also think of it as to over of. Those are just some other ways to kind of think about this. So let me explain. Let's do example 2 and see what that looks like. What is the scale factor of quadrilateral ABCD to quadrilateral EFGH? ABCD is the shape on the left. EFGH is the one on the right. We're going from the one on the left to the one on the right, which means the one on the right is the new shape, and the one on the left is the old shape, because we started with the old shape and we went to the new shape. Also look for those keywords of to and of. Here's of and here's to. Whatever's after that word goes on top, or is the, whatever is after that word is what it's talking about, new or old. So what I'm trying to say, the to, what's after to is EFGH, that's the shape on the right, and after the word of is ABCD, that's the shape on the left. So if we put the shape on the right over the shape on the left, that's still new over old. So when you do this, you get to decide which two sides correspond. It doesn't matter. Any two sides that correspond. Now we have 4 pairs of corresponding sides to choose from. Let's just choose 2 of them. Maybe let's do the 10 and the 5. So remember, we want to put the new over the old. New over old, or 2 over of. The new is the 5 because it's from the new shape. The old is the 10 because it's from the old shape. There's my ratio. The last thing I need to do is just simplify it. If you put this in your calculator, you'll either get 1 over 2, which is acceptable, fine, or it might convert it to a decimal as 0.5, also okay. I would like us to kind of stick with the fraction version. Now, what I want to point out here, pay close attention to scale factor. If my shape is getting smaller, like this example, I'm going from the big shape on the left to the smaller shape on the right, my scale factor is going to be less than 1, which it is. 1/2 is less than 1. However, if I'm going from a smaller shape to a larger shape, the scale factor is going to be greater than 1. So let's write it like this. Scale factor is less than 1 when you're getting smaller. Scale factor is greater than 1 when you're getting bigger. Okay, so write yourself a little note off to the side. It's good stuff. And that'll kind of help you. You can always kind of like check your answer for reasonableness. Yes, my shape is getting smaller. Yes, my scale factor is less than 1, so that makes sense. Now 3 says, show that the ratio of the perimeters is the same as the scale factor. Okay, so the ratio of the perimeters. Remember, perimeter is add up all the sides. So I'm going to keep my, I'm going to keep the new over the old. I just need to figure out what those new and old perimeters are. So let's do, we'll do new perimeter over old perimeter. We're still making a ratio. So the new perimeter, I want to add up the 2.5, the 5, the 4, and the 3, and that's going to give me 14.5. So that's going to go on the top. For the old perimeter, we want to add up 5, 10, 8, and 6. That's going to be 29. That's going to go on the bottom. That's the old perimeter. So then you just type that fraction in your calculator, and it'll probably, since you have a decimal, it'll probably automatically convert it to a fraction, which is 0.5. Sorry, a decimal. Or, you know, that's the same as the fraction 1/2, excuse me. Okay, now I want you to notice here, this is super important. I want you to put a star here. Notice that these are the same. So what is the same? The scale factor equals the ratio of the perimeters. Scale factor and ratio of the perimeters is always the same. So rather than, if I'm asked for the ratio of the perimeters, rather than adding up all the sides to get the perimeters and then making a ratio, just pick 2 sides that correspond and find the scale factor, and now you know the ratio of the perimeters, and it's much easier. All right, in the last example, we are asked to find the scale factor again, but this time of quadrilateral EFGH to quadrilateral ABCD. So this time we're starting with the one on the right and we're ending with the one on the left. Okay, look where your of and your 2 are. So that means the one after 2, that's your new. This is the new shape. The one after of, which is EFGH, that's your old shape. So the new and old are flip-flopped. So I can use those same 2 sides, the 10 and the 5, but now I'm going to switch them. So remember, scale factor is new over old. So let's use the 10 and the 5 again. Remember, the old and the new are now flipped. Okay? So the new shape is now on the left, which is the 10. The old shape is now on the right, which is the 5. 10 over 5 is my ratio. Type that in your calculator. That simplifies to 2. So 2 is the scale factor. Notice 2 is bigger than 1, right? And if I look at the shape on the right, going to the shape on the left, I can see that it is getting bigger. So my scale factor makes sense. In this example, we're going to first determine if the figures are similar. So we're not being told they're similar, we have to figure it out. So remember the two things that must be true in order for polygons to be similar. Corresponding sides must be proportional, corresponding angles must be congruent. All right, let's start first by seeing if the corresponding sides are proportional. Now first we have to figure out which sides actually do correspond. So first of all, these shapes definitely could be similar. They both have 3 sides, so they're both triangles. Remember, the short sides are going to go together, the long sides are going to go together, and the medium sides are going to go together. So let's look at the 2 short sides first. We've got 2 and 3. Now, we're not finding scale factors, so it doesn't matter which number I put on top and which number I put on bottom when I make my ratio, but I want to be consistent. So let's do the smaller number on top. I don't know, the one on the right on top of the one on the left. So let's do 2 over 3. There's 1. Remember, to test if sides are proportional, you have to make ratios with all the sides and then make sure that they're all equal. So let's look at another pair of corresponding sides. Let's look at our large sides. That would be the 12 and the 18. I'm going to put the 12 on top of the 18. The right one over the left one. And then my last 2 sides that correspond are the 9 and the 6. I'm going to put the 6 over the 9 because I'm trying to be consistent. So these are the ratios of my 3 sides. Now in order for them to be proportional, all 3 of these ratios need to equal each other. The easiest way to tell is just to reduce them all and see if they reduce to the same thing. You can type these right into your calculator and it will reduce them for you. If you type in 2/3, 2/3 equals 2/3. It simplifies to 2/3. 12/18, if you type that in your calculator, that will also simplify to 2/3. And then if you type 6 over 9 in your calculator, that'll also simplify to 2/3, meaning these ratios are all equal, meaning the sides are proportional. So 1 checks out. Number 2, we have to see that corresponding angles are congruent. Okay, so the right angles definitely are congruent, right? Those are going to match. Now I am missing some angle measures, but I remember in a right triangle, the 2 acute angles always add up to 90 because the 3 angles, the 2 acute with the 90, need to add up to 180. So if this angle down here is 53, this angle up here would have to be 37, so that it adds with the 53 and the 90 to make 180. And then on the left triangle, that bottom right angle would also need to be 53. So I can see my 53s match, my 37s match, my 90s match. So my corresponding angles are congruent. So because both this and this are true, we can say the 2 shapes are similar. Don't forget, this symbol means that they are similar. Okay? All right, we've got some examples to try to apply some of this stuff. So 6 says, use the similar figures below to answer the questions. I can also see that they're similar by this symbol, right? First thing, we're going to finish the similarity statement. Now, it's just like the congruent statements we did with congruent triangles. The letters need to correspond in the same position, okay? So I can look at the angle markings to determine that. So E is going to go with A, because they both have 1 arc, E and A. F is going to go with B, because they both have 2 arcs. Oops. G is going to go with C, because they both have 3 arcs. And H is going to go with D because they both have 4 arcs. So A, B, C, D. That's how they correspond. Okay? And we can also use that when we're setting up ratios. What is their scale factor? So remember, scale factor is new over old. And I get to choose any two sides that correspond that I want to make my scale factor. Now what we don't know here is what's our new and what's our old. So if you're not told, you get to go with whatever one you want. It doesn't matter, whichever you want to be new or old. I like to say that the one on the left is the old shape and the one on the right is the new shape, just because we read from left to right, so it makes sense to me. So let's pick two sides. Now some of these sides are variable, so we definitely need to choose the two sides that we have numbers both for, and that's going to be these two sides. So remember, I want to do, remember scale factor is new over old. So I'm going to do the 10 over the 2.5. Okay, the 10 over the 2.5. So type that into your calculator and that will simplify to 4. Okay, and you can see, yes, that's bigger than 1. Yes, my shape is getting bigger as I go from left to right. Okay, find the following, x, y, and z. So this is where you would want to either use the scale factor or set up a proportion. So proportions are really big in this chapter. So if you look at the scale factor, go back to that 2.5, right here. If I multiply it by 4, which is my scale factor, I get 10, right? I can use that same pattern for all of the sides. So for x, I could think, okay, what times 4 gives me 12? It's 3. For, let's see, y. 3 times 4 gives me 12. Y must be 12. And then for z, what times 4 gives me 5? Not as easy. So this is where you might want to set up a proportion. Here's how it could look. Let's use the 10 and the 2.5, those two sides. And then maybe also, well, the two sides we're trying to find, the z and then the 5 that we know. So we want to set up our proportion with these corresponding sides in the same way on the left and the right side. So let's look at the yellow sides. Let's put the 10 over the 2.5. Okay. For the green sides, I got to set it up the same way. So I'm going to put the 5 over the z. Here's my proportion. Remember, now you just have to solve. So you cross multiply, right? 10 times z is 10z. 2.5 times 5 is 12.5. Remember, these are equal. To solve for z, all I'm going to do is divide both sides by 10. And z equals 1.25. So 1.25 times 4 is going to give me that 5. Okay, so that's how you could do the sides. You could also go from the right sides to the left sides by dividing by 4. 5 divided by 4 is 1.25. Okay? All right, D says, what is the ratio of the perimeters? Don't get tricked up by this. There are no calculations you need to do. Remember, scale factor and ratio of the perimeters are identical, so it's also going to be 4. So rather than taking the time to add up the perimeters of both and making a ratio and reducing it, just get the scale factor and rewrite it because they are the same. All right, let's try some more. All right, here's another one. Again, it says use the similar figures. So we know they're similar. We know we can set up proportions with the sides, and we know that the angles that correspond are congruent. Find the scale factor of polygon RSTUV to polygon ABCDE. So remember, scale factor is new over old, or, remember we also said 2 over of. So ABCD is the right triangle. that's going to be my new. I'm sorry, not triangle, pentagon. RSTUV with my of, that's going to now be my old. Okay, here's what you could also remember. Old and of both start with an O. That might help you as well. All right, so let's use some of these numbers. You get to choose any two sides that you want that have numbers on them. Let's go ahead and choose the 18 and the 4. I think those are the only ones. Now we want to put the new one, which is the 4, over the old one, which is the 18. Type that ratio into your calculator. It should simplify it to 2/9. So that is the scale factor. Now, find the values of x and y. So first of all, my scale factor is 2/9. So that means I can take all of the sides on the left, multiply them all by 2/9, and I get all of the sides on the right. Or I could set up a proportion like we did in the last example with some sides that correspond and solve for the missing side. Okay, a couple different ways to do it. I like the proportion way. So I'm going to use the 18 and the 4, but then maybe I'll also use, for the x, we'll have to use the x and the 3 because those correspond. So the way that I might set up my ratio, it doesn't really matter. I might start with the x and the 3. However you set up one side of your ratio, you need to set the other side, the other ratio in your proportion the same way. So I did left over right. So with my 18 and 4, I'm going to do the same. I'm going to do the left one over the right one. Just make sure the left and the right part of your proportions are set up the same way. All right, now we'll go ahead and cross multiply and then solve. X times 4 is 4x. 3 times 18 is 54. Those are equal. To solve, divide both sides by 4 to isolate your x. And x equals, what is that, 13.5. All right. Is that right? Okay, good. You can also write it as a fraction. It would be 27 halves, either way. Okay, now we're going to do the same thing with our y's. Now, I want you to notice the side with y is actually y plus 2. So when I make my ratio with the y plus 2 and the 5, it doesn't matter which one I put on top or not. Whoops, I wanted to use blue. Excuse me. But I just need to be consistent. So maybe I put the y plus 2 over the 5. And then again, let's use those yellow sides. That will be equal to the 18 over the 4. Now when I cross multiply, what's very important is that I put parentheses around that binomial, the y plus 2, so that when I cross multiply it with the 4, I remember to distribute that 4 to both the y and the 2. So what we're going to get, and I don't have a whole lot of room, I'm going to go way up here where I cross multiply. So we'll have 4 times y plus 2, and then the other cross product is 5 times 18, which is 90, and these are equal. So the first thing we'll do is distribute that 4. 4 times y is 4y. 4 times 2 is 8. That equals 90. To solve for y, we want to first get all our constants on the other side of the equation. So we'll subtract 8 from both sides. So 4y equals 90 minus 8, which is 82. And then we'll divide both sides by that 4 to get the y by itself. 82 divided by 4 is, what is that? Oh, 20.5. 20.5. You could also write this as a reduced fraction, 41 halves. All right, now if I take that x, 13.5, right, and I multiply it by 2/9, I will get 3. If I take that y of 20.5 and I put it here, and I add 2 to it to get 22.5, and I multiply by 2/9, I will get 5. All right. For example A, we're not going to do it together, but if you want to pause the video and try it on your own to see if you get it, pause now and then press unpause in just a second and you'll see if you got the right answers. Here are the answers to this one. One thing that is important to remember is that the sum of the interior angles of a quadrilateral or four-sided shape equals 360. So you need to know that to find this angle right here. All right, if you have any questions on this one, just write them down, and then when we get to class, you can ask them. In these last two examples, you'll need to draw pictures because there aren't. One is dealing with sides, and one is dealing with angles. And you're going to have to set up some equations here. 9 says, if the lengths of the sides of a triangle are in the ratio of 3 to 5 to 7, its perimeter is 120 centimeters. Find the length of the shortest side of the triangle. So first, let's draw a picture. Any side of any kind of triangle you want to draw. The sides are in the ratio 3 to 5 to 7. So we don't exactly know how long they are, but we know that if they were all multiplied by the same number, we could get the sides, but they need to add up to 120. So we could call one side 3x, just put an x with the 3. We could call another side 5x, put an x with the 5, and then the other side 7x, put an x with the 7. Okay? If we add these up, the perimeter is supposed to equal 120 centimeters. So we can make an equation like this: 3x plus 5x plus 7x equals 120. Now that we've made an equation, we can solve for x, and once we know what x is, we can plug it back in to find the shortest side. So the first thing we want to do here is combine these three like terms, 3x plus 5x plus 7x. Those all combine to make 15x. And then the last thing we'd want to do here is divide both sides by 15. 120 divided by 15 is 8. So x equals 8. That's not the shortest side, though. That just tells you this number to multiply the 3, 5, and the 7 by to get the three sides. Now we just need the shortest side. So the shortest of these is going to be the one with the smaller factor in front. That's going to be the 3x. So we're just going to replace the 8 part for x. Sorry, the x part with 8. I'm not speaking right. And that will equal 3 times 8, which would give you 24 centimeters for this shortest side. If I wanted to go a step further, I could find the length of the other two sides by replacing those x's also with 8. And the three sides should add back up to 120 if we did it correctly. So that was an example with sides. Now let's take a look at an example with angles. The measures of the angles of a triangle are in the ratios of 1 to 2 to 3. Find the measure of the largest angle. So just like before, we're going to just sketch a picture of a triangle. We're going to stick an x with the 1, the 2, and the 3, and we're going to put those where the angles are. So we've got 1x, 2x, and 3x. We don't know how big these angles are, but we should remember what they add up to. If I were to add these up, they should all add up to 180. Never forget that. So now that I have an equation, I can go ahead and solve it. Let's combine our like terms. 1x plus 2x plus 3x is 6x. And then we can divide both sides by 6. And x equals 30. Remember, that's not your answer. That just tells you the value of x in these three expressions. We want to find the measure of the largest angle. That's going to be the one with the largest factor in front, or the 3x. So we're going to replace the x part with 30. 3 times 30 is 90. So that angle is 90 degrees. The largest angle is 90 degrees, meaning this is a right triangle. Now notice, my picture wasn't drawn to scale. That doesn't look like a 90-degree angle, but it doesn't matter. All I needed to do was to draw the picture so I could organize my information. All right, if you have any questions, make sure to ask in class. See you later.